welcome back. I've got an amplifier here. It's a Lenco 850. I think it's from end of the 70s. I also got a copy here of the service manual. And does it have a date somewhere? I think it's from 77, if I remember correctly, from Radio Museum. This amplifier was gifted to me because it doesn't work anymore. The person that owned it wanted to throw it away, wanted to dump it in the bin, let's say, because there was one channel broken. Apparently there was a short on the, I think, right channel, and the fuse of the right channel is blowing. So he wanted to throw it away, and I said, yeah, just let me have it, I'll have a look at it. And so now we can have a look together here and see if there is something, what is wrong, and if it is worth to repair. And if it is not worth to repair, then I can always use it for spare parts. I can at least recycle the parts. So Lenco was a Swiss brand, if I remember correctly. And they went bankrupt in the same year as this model was released. And it's actually not a real Lenco anymore. It was made by a Korean company. Yeah, so a quick look. It's called Seum Electronics or something like that. It's a Korean company, and they built this for Lenco. Lenco just batched their name on it and resold it, basically. It was also available on in other brands. It's like a generic amplifier that was rebatched with different brands. It's a 40 watt per channel amp, and 40 watt into 8 ohms. Nothing special, but could still be quite nice. I do like the look of it. Yeah, it is quite dirty, so it will need a bit of cleaning up as well. And on the back. So yeah, you do have quite a bit of options. There are 2 phono stages. Well, not 2 phono stages, there are 2 inputs for phono. You have tuner, 2 auxiliaries, so you have 5 inputs in total. And then you have 2 tape inputs and also tape in and out via DIN. 2 sets of speakers, resistors, fuses for both channels, and preamp and main amp separators. So that is actually not that bad. Here on the front we have the usual VU meters, volume, loudness, stereo mono, treble and bass. This is the mode switch, see, with 2 phonos, a tuner and 2 auxiliaries. It has a built-in mic amplifier, so with which you can turn off here, and then the level. Then the LEDs which indicate the position or the function that you have selected. That I think is a bit weird. Maybe I find it a bit tacky. So I do like the style of this front plate, except these LEDs, they look quite cheap actually. This one is loose. Balance control, tape monitor. These are your tape controls: copy, high filter, low filter, and your both sets of speakers. Headphone input and power on off switch. Yeah, it's quite dirty. Some of the knobs here are bent, so we will have to have a look at that as well. I think first thing I'm gonna do is give this a quick clean, open it up first before we apply power, because I know that there is something wrong with this, and I just want to check if I don't see anything obvious which has blown up inside before we put some power on it. Maybe I can check the fuses, because yeah, they said one fuse was blowing. This one seems okay. Let's do a quick continuity test on the fuse. Wow. Unbelievable. Yeah, so this one is fine. That is the left channel. If I remember correctly, it was the right channel that had issues. There is something in this fuse. I think that one is blown. Oh no! So let me simply give this a quick wipe and open up the case, and then we can see if we can find something inside. Okay, let's have a look. Okay, that doesn't seem too bad on the inside at first sight. Relatively clean as well. What is this? There is a transistor here glued to this heatsink. Okay. Somebody really has already been in here, because see, 2 of these have been replaced, and I think 2 are still originals. Okay. So this is an C828. Very weird. What is this doing here? Okay, so see here, this transistor is missing, and there is a transistor here glued right above it in this, with this tape. So I think somebody stopped here in the middle of a repair, because here on this side, see, the transistor is still present. How do we start with this? Maybe I'm going to open up the back panel as well, and yeah, maybe we can start measuring or start testing some transistors here. Okay, so this transistor here that was glued here with this piece of tape is definitely bad. See? It tests 2 diodes. So what I think is something went wrong here in this channel. This transistor is one of the things that blew, probably. And probably the previous repair tech didn't have a replacement and just temporarily taped this transistor here just as a reference, because that's the one that came out of here. That one is definitely bad. The bottom side actually looks quite okay. And everything is quite neatly accessible, which is good. I do have the schematic over here, and I did some coloring on it just to make it a bit more readable. Okay, so the right channel here is a mess. I think quite a catastrophic event happened here at some point. Maybe we can have a quick look at the schematic over here. Does this show up well? Yeah, I think it's fine. So this is the PCB with the main amp. That's the left channel. This is the right channel. The one that was marked here is the one that was removed and that was sitting in the under the tape. I found another one which is removed, and that's over here. There's another one missing, Q521. So that's the equivalent of this one over here. And if I start measuring, here this resistor also has been replaced at some point. So if I've been checking a bit the transistors over here, and there are some which are clearly not okay. See, so let me show you this one. That's reading a diode drop of 0.3, which is not really what it should be. See, and that link is just, well, that's a short, see, from base to collector. So that one is shorted as well. That's Q518. That's that one over there. So maybe, I can go over the schematic in general a bit later maybe, but just for this purpose. So this is the amplifier for the right channel. And here in the middle, you have a quite weird protection circuit, quite unique. And it's also explained in the manual how it works, but it's a bit weird. And that transistor is part of this protection circuit, and that one shorted clearly. You can also see it if I measure these diodes. I will show you now. I will measure these diodes and I will compare them to these, and you'll see that there is also an issue there. So these are these two diodes. So if I measure this one, see I have a 0.6 of a diode drop in one direction, which seems fine, and in the other direction I have 1.4. The other diode again in the correct direction, 0.6, and in reverse 2.3. But then on the other channel, see again 0.6, but in the other direction open, which is what it should be. And here the other diode as well, 0.6, and in the other direction again open. So I think well, this transistor is definitely bad. There is one which is missing, which needs to be replaced. That one which we took out, which was already taken out, needs to be replaced. And I'll guess will not be the only part here in this circuit that needs to be replaced. So yeah, how do we start with this? I'm gonna try to find some suitable matches, some suitable equivalents. I'll probably will have to order some yeah, replacement transistors for these, and then I'm gonna go through the entire board here and see what is bad, which components are bad, and then, well, I hope to get it running again. Yeah, so I pulled this one Q518, I believe it is, and it's in the tester here, and yeah, it's bad. It's a resistor. So that's already good that we find that one. And I marked here the ones which need to be replaced. That's the Q518, and the other two, there are the ones that were already removed from the board. So yeah, we are on the right track here. Okay, so let's check these diodes now that I have this faulty transistor removed. Forward voltage drop 0.6, reverse open. That's already a lot better. Let's check the other one. Forward 0.6, reverse, still 0.3. So there is still something bad as well. Maybe it's Q517, the other transistors in this weird protection circuit. Where is that one? 517, that's this guy over here. Forward we have 1.9. That doesn't look right. That should be a normal voltage drop. This is an NPN. I have the positive on the base, the negative on the emitter. 1.9, that doesn't look right. And to the collector, 0.1. So that's also opened, yeah, shorted, I think. Okay, it's out. So this is Q517. Let's put it in the tester and see if it's also bad. I guess it will be bad. Yeah, it's a 26 picofarad capacitor. So let's just make sure that we have good contact, test it again. Yeah, it's also bad. So that's number 4. 4 casualties already in this right channel. I'm just gonna go ahead and see if I can find more things that are cooked here. Okay, so at first sight here in the rest of the right channel, well, I haven't checked everything, but I did spot check the transistors that are still on here. They seem to be fine at first sight. The diodes are also now measuring correctly. The resistors in this protection circuit, they are also measuring correctly here on the right channel. So that seems fine. And then I did a quick check here because I had colored this in already earlier, this weird protection circuit. These are these 2 orange lines. We have one darker orange and one lighter orange, and they get their voltage from the power supply. sorry, that wasn't in focus. So see here you have these lines, they are mentioned, yeah, or marked with PRT, so I guess that means protection, positive and negative. So they have a positive and negative power supply. They go here, get their voltage here from the power supply board. So I decided to also check here on the power supply, because I figured maybe if something went wrong here, it blew out something there. So that's these two transistors over here, these small ones, Q601 and Q602. That's these two guys over there. Let me show you what I found. So here, this is Q602, that's an NPN. So if I measure from base to emitter, I've got a voltage drop of 0.637, and base to collector, 2 volts. That doesn't seem right. And collector to emitter, 1 volt. And the other one, 601, that's an also an NPN. Base to collector, 0.6, and base to emitter, also 0.6. So that one, at first sight, seems okay. But this one, I think it's bad. Let me pull this one as well and see what we have over there. Alright, so this is Q602 pulled. That's a 2SA561. Let's put it in the tester. Let's put the legs in the correct places. Yeah. And let's see. This one still tests as a transistor? That actually tests okay in circuit. Yeah, out of circuit. Alright. Okay. That one is still fine. So I'll have to put it back. I found something rather interesting here. So this resistor, R549, and here on the left channel the equivalent is R523. They should be 330 ohms, and here on the left channel, indeed, I measure, yeah, more or less 330 ohms. On the right channel, however, 450. So that one has gone high. And it's a 330 ohms 1 watt, I think. Yeah, 1 watt resistor. And if I put you a bit closer, you can also see that it has been suffering a bit. See, it's that guy. You can see the burn mark clearly underneath the resistor here on the board. So something has gone wrong here. Now, what makes this even more interesting, let me show you the schematic. So it's that one over there, R4539, 330 ohms. And that one is here is the one which is still okay on the left channel. Now, look at where they are going. They are going to the headphone output. So this is the resistor. This resistor is in series with the headphone output, and it's connected straight to the output of the power amps, basically. So has someone created a short here with a headphone? Or maybe headphone plugged in incorrectly, or a faulty headphone, or maybe there is a short in the headphone socket. And no idea, but I think that's the only way why you could get such a high current here through this connection, that this resistor goes high, or this resistor really burns up. Maybe that was the start of all the issues that we had here in the right channel. So yeah, that's also one that we need to replace. Hey, look at this. This is the headphone jack, and see, it is completely loose. You can just wiggle it around. So what I guess happened here is that someone plugged in a headphone, and one of these pins of the headphone jack must have touched the PCB, which is sitting above. And those are the speaker selector PCB. So yeah, I think ground must definitely be running over that PCB. So they must have created a short here. I don't know Oh yeah, it just plugs out. It just comes out like this. See? Okay. Is this bracket here messed up or what? How come this is so loose? Well, I don't know yet. I'll have to check, but it's definitely, I guess, the reason why this, why this resistor burned. Yes, it's broken off. See, here it is. Wait, let me focus. See there, it's broken off. So we're gonna need to replace the headphone jack, I guess. And I guess that's the reason why that resistor burned up or got overheated. If that's also the reason why we have all the problems here in the right channel, could very well be. Could very well be. And I've also found a broken wire here. This one was loose, so I soldered it back. And that's actually the input for the right channel. So it's the signal coming from the preamp, or yeah, the input for the amplifier of the right channel. So lots of things going on here with this right channel. So what I would like to do here is attempt to power this up through the dim bulb limiter. Even though I do have quite a number of components missing in the right channel, I don't think that should be an issue for the left channel. I also took out the fuse for the right channel. Just want to see how it performs, what kind of voltages do I get out of the power supply, and what is the left channel doing. The problem is a bit, what is quite annoying, is that there are no voltages whatsoever anywhere on the schematic or nowhere in the service manual. So I don't know exactly what voltages should be there. So that's also interesting to be able to see that. I have got one bulb in series. It's a 25 watt bulb. And yeah, I think, and I have not replaced any of the capacitors. I think they should still be fine. I spot checked some important ones and they still seem to be rather okay. So yeah, I think we can see what we get here. So the dim bulb is on, and let's turn on this thing and see if we have an issue or not. Okay, we had a very, very bright lamp for a second, and then it dimmed down. It's at 210 volts, it's pulling 9 watts, and I do have a LED here that is lighting up. So that seems good. Yeah, and the switch is working between the channels. That's fine. I have two out of 3 bulbs here are working. There are three dial bulbs. 2 out of 3 are working, so that's also okay. Yeah, and nothing seems to be blowing up. Let's see, what do we get in terms of DC offset at the left channel? Let's be optimistic and put it to millivolt. $150 millivolt, that is quite high, but that's maybe also because we're only at 220 volts. If I go to 220 volt, yeah, no, 150 millivolt. Now let's see what kind of voltages we have here on this power supply. Let's immediately go for the B plus for the main voltage for the output transistors. This is 612. That's 34 volts. 613. That's minus 34 volts. Now the problem is I don't know how much this should be, but it is quite balanced. So that actually seems to be okay. Then we have the second power supply for the preamp and the phono stage. That's P601. That's over here. That's 14 volt, and that's spot on 14 volt. That sounds about right. With this minus 150 volt, or with this 150 millivolt DC offset on the output, I'm not really keen on hooking up my speaker actually. It's 140 now. Well, because I need to access the front here as well, because I want to, yeah, I will need to replace this, no, here, this, the phone jack, and also this LED that is loose. I want to take the front panel off. There are 3 screws here on this side, and here on the top side, the middle one is missing, so we only have 2 screws here on this side. But first we're gonna need to take all the knobs off. Let's see if they come off easily. So, yeah, okay, so these knobs, yeah, they come off, that's quite okay. Oh, that's the metal cap that came off. That will need to be glued back as well. Yeah, here as well. Yeah, another one. Oh! And let's see if these come off. Okay. There is like a plastic piece of washer here. Okay. They come off rather well, which is a pleasant surprise, because sometimes they all have these plastic washers. Sometimes it's just a nightmare to get these knobs off. Okay, that's a nice touch. Okay, I think all knobs are off. Now, let's take these screws out. Now on top. Okay. All right. Oh, these LEDs, they are fixed to the front plate. Yeah. Oh. That's just a matter of gluing it back, I believe. See, so these LEDs, they have their plastic, yeah, mounts, don't know how to call it, with a connector. And this one just came off from the front panel. So it's a pity that there are 2 with the same color. So we have red, green, blue, yellow, and then again blue. But yeah, doesn't really matter. If I swap them around, I will notice, I think, if I put them back incorrectly. Okay, front panel. Let's put it to the side and give it a clean. Now, I don't want to jinx it, but so far it seems that this amplifier is built rather conveniently. I mean, lots of things have rather easy access, except here this board for the, I don't know what board this is. Yeah, for the switches here. Because here you have two boards on top of each other. See, here is one, and then underneath there, here is another one. So if there are capacitors, yeah, there are caps on here. If I want to change these, then this board will need to come out. See, let me show you. See, so this board over here, I don't think that's easily serviceable because they can't get to the underside. But all the rest seems to be quite okay. This is the remaining part of the headphone jack that just fell out. See, it's clearly broken. So we're gonna have to get a new one for that. So I am going to try to glue this back with super glue. Now I have no clue if this will hold. We will have to see. I can try it. There is nothing to lose here. Otherwise, I will just replace the connector. I'm using this. This is super glue, not instant glue. So it should hold quite well. But the nice thing about this glue is that it doesn't dry instantly. Well, in some applications that's annoying. If you really need to hold it two pieces together, then it's quite annoying if they don't snap into each other instantly, or if they don't glue to each other instantly. But in a case like this, it's actually quite convenient that you can take your time to apply the glue, let it dry a bit, and then snap the things together. And I hope that they go together. Yeah. I might have applied a bit too much glue here, but okay. Now let's wipe the excess. It is drying a bit, but not too much. Don't try to get glue into the threads of the screw thread here. I think this might work. Let's see if I can wipe off the excess here. Really make sure that there is no glue in the threads, stuck in the threads, because then, yeah, it won't work. Yeah, seems to be okay. Yeah, it's working. Yeah, it gets all the way to the back. That's nice. So just gonna let this dry, and then we can put it back and see if it holds. But maybe it's a good idea to put some sleeving here over these contacts, so that if it breaks again in the future at some point, that it doesn't short out the amp, and that we don't get the same problems again as we have today. So I'm gonna do that as well. So yeah, the connector is back, and I think it's okay. I don't think this will come off again. I put quite a bit of glue in there, and yeah, it's quite snug. So I think that's fine. I also, as you see here, heat shrinked all the 3 connections. These tabs here, they don't make connection to the circuits. They are just for mounting on a PCB, I think. Yeah, I think this is fixed. It's always better if you can fix an existing component instead of having to source a new jack or a new socket, because it'll never fit. Well, yeah, you have a high chance that it won't fit perfectly, and yeah. I'm quite glad that I could solve it like this. So, yeah, I think we are quite done here for this video. I'm gonna order all the components that I need, mainly the replacement transistors that I need. And in the meantime, yeah, I'm a bit stuck. I could start changing capacitors, but honestly, I've been testing most of them quickly with the ESR meter, and not a single one was bad. They all had good ESR. Even the capacitance tested good, even though they were in circuit. Also, the big ones here, the 8200 microfarad ones, they tested really good. They tested at, I think, 0.3 ohms ESR. So, I don't know what to do with these capacitors actually now. I'm considering just leaving them in there. Most of these are gray. These gray ones, they are all from the same manufacturer. And I think, honestly, that this amplifier is quite a low hour set. I don't think it has been used much. It must have broken down quite early on in its life. And I don't see any capacitors that are completely exhausted. So I need to think a bit about this and see if I'm going to replace all of them, because I think most of these will still be perfectly fine. Maybe it's an idea to try to get it working first, both channels, and then see what we can do, or if we are going to change the capacitors, just see how it performs with all the original ones in there. That might be also an interesting exercise. Yeah, there is also here this bulb. There are 3 bulbs here in the VU meters. One of the 3 is blown. The other 2 are still working, which also is an indication, I think, that it hasn't been running for a huge amount of hours. But these are these annoying type of bulbs where they have the wires directly going into the socket of the bulb. And yeah, it's not easy to replace. So what I'm gonna do, I think, is mount some warm white LEDs in here, and yeah, make a circuit that make sure that they don't flicker. I think that's the best approach, because these are 6.5 volts, 80 milliamp. Yeah. And then the switches, obviously, I might need to start also cleaning the switches. But yeah, that's basically it for this video, because I can't do much more. I need to wait until the replacement transistors arrives. So yeah, I'd like to thank you for watching, and I'll see you in the next video about this nice little amp. So take care. Bye bye.